equations with algebraic fractions. Let's start with a simple equation that has only numbers as denominators. The best way to handle solving an algebraic equation with fractions is to clear the fraction. And we know you can clear fractions if you multiply both sides by the LCD. So that's what I'm going to do. The LCD, or the least common denominator, in this equation is 6. So I'm going to multiply both sides by 6. As long as I multiply both sides by 6, I do not change the quantity of the solution to the equation. So we have to use the distributive property here. The first term, that would be 6x over 2, which is 3x. The next one would be 6x over 3, which is 2x. On the right side, since 1 6 times 6, the 6's cancel, I get 6 over 6, you would just get 1. So now I have an equation to solve without fractions. So let's go ahead and do that. 5x equals 1, or x equals 1/5. So our second example, a little tougher. The LCD between the three fractions would be, well, the numbers would be 12, and we also have an x, so 12x. So let's multiply both sides by 12x. Doing this is a little more tricky because we have two terms inside here, so we still have to use distributive property. So when you take 12x times the first one, the x's cancel and so do the 2's, so you end up with a 6 with a x plus 1. If you want to see that step, it would look something like this, and you can see that the 2's cancel and the x's. The next one, the 4 would cancel with the x's, so you end up with just a 3 with an x minus 1. Again, seeing that step, you can see that the x's cancel as well as the 4's. The right, you don't have to use distributive property, so I'm just going to put that over 1. And on both of these, just the 3 was cancel, so you end up with a 4x. So now we have an equation without fractions. So we can do this like we did in the past chapter. Just use distributive property, combine like terms, subtract 3x from both sides, leaving you with 9 equals x, or x equals 9. So that's the two answers that we got in our first two examples. You do have to be careful, because if your denominator it is 0, the whole thing would be undefined. If you notice that the domain, the denominator of these functions cannot be 0. So I need to show you an example where you might need to cancel out an answer if your denominator is 0. So to show you that, let's do our final example, solving this equation. Again, this is an equation. We're not adding these fractions. We are actually solving the equation. So we're going to do the same rule, multiply both sides by the LCD. So what is the LCD here? Well, the second, or the term on the right, actually does factor to the difference of two squares. So rewriting the left, you can clearly see that the LCD, therefore, is 1 of each factor. So there's an x minus 2, which again is totally different than an x plus 2. Because if x is 5, the x minus 2 would be 3. And this would be 7 and 3, and 7 have nothing in common. So that's what I'm going to multiply each term by. Doing this, on the first term, the x minus 2's cancel. So you end up with a 3 and just an x plus 2. On the second term, only the x plus 2's cancel. So you end up with a 5 and a x minus 2. On the right side, the whole denominator cancels, so you end up with just a 12. If you want to see this step a little more closely, you have to multiply this together to get, and this shows you that the x minus 2's cancel. On the next one, we multiply the same term, distributive product, because we have two terms. And you can see the x plus 2's cancel there, giving us that second term. And the right-hand side, you can clearly see that you would get 12. So I won't do that one again. Okay, let's go ahead. Now we have an equation without fractions, so we can easily solve it by getting rid of the parentheses, combining like terms, adding 4 to both sides, dividing by sides by 8 to get x equals 2. Okay, the problem with x equals 2 is, you notice it makes the left side right here, if I plug in 2, undefined, and also the right side. This one actually, this middle term is okay. So x minus 2 cannot be a solution, even though it was a solution to that linear equation. The reason this happens is because we end up, since x was 2, multiplying both sides by 0. So you get 0 equals 0, and it cancels, anything can happen. It cancels everything out. So when this happens, you need to cross off that solution. If there's more than one, only ones that do not work will be crossed off. But if it is the only one, then there is no solution, which is this case. So that is the answer.